All right. It might be kind of a quick meeting today. We don't have Sage. I do believe, though, that I will try to maybe show some memory allocator results today. Let me get all my stuff together. All right. Not a whole lot happening in terms of pull requests over the last week. There's a new one by Majian Peng that looks interesting. It changes some of the behavior of the KV sync thread in BlueStore and the way the finisher thread works. I have not looked closely at this. The only thing I asked Majian Peng for was if he could run it through the wall clock profiler, because that might tell us a little bit more about kind of the change in behavior. He did show really good performance improvement results, though, with like high concurrency. So that could be interesting. Anyway, hopefully we'll get more information on it or get a little bit closer. Let's see. Oh, there's Radix stuff here for the static linking. What else? Oh, and then Adam's work looking at bitmap allocator fragmentation, Igor's bitmap allocator. I actually have no idea what kind of fragmentation we see with it now. I guess Igor, you're here. Is there any new news on that, or what's kind of the status of that?
Well, actually, I'm still reviewing that, and well, probably the results are pretty expected since bitmap allocator cares more about performance than fragmentation. Well, I have some thoughts on maybe introducing some caching for above bitmap allocator to fight this fragmentation issue, but still uncertain about that.
So one question I have is that it looked like stupid allocator at one point was maybe fragmenting things badly as well. Is bitmap allocator worse, the new one?
Well, actually, if your actual allocation of the store isn't is not fragmented, then stupid allocator probably behaves better because it properly allocates the continuous segment first, while bitmap allocator looks from the beginning and just collects any available extents. So resulting list might be fragmented, and it doesn't care about that. The question is actually what's the actual fragmentation in production system over the time.
Yeah.
I suppose nobody knows that in detail, and in that case, it's questionable if stupid allocator is better or not.
One mechanism to kind of, or one test to look at this in a not a direct way, but kind of an indirect way that I've had luck with in the past is just alternating doing like 4K random writes and then like 4 megabyte sequential reads in like an RBD volume, so that you have 4 megabyte objects, but you're kind of alternating between doing small random writes and big sequential reads, and that's like with ZFS with file store, or sorry, Butterfest with file store, it was really, really easy to see the copy on write behavior and fragmentation that would result from it when you did that.
Yeah, maybe, but well, again, it hardly depends on the right read patterns, and well, all these artificial test cases might be completely different from the actual production system, you know.
Sure, sure.
And well, again, Adam's benchmark here is again it's artificial. So.
Okay.
But as I said, generally, stupid allocator is more aimed for fragmented allocations than bitmap one. So by design, it has some benefits on that.
Sure.
At the cost of performance. And yeah, maybe it really makes sense to have different implementations for rotational drives and for drives.
Sure.
Maybe we don't need that high performance for rotational drives probably. While fragmentation is important there.
All right. Well, sounds good. It'll be nice to see actually comparisons between the two, just because it looks like, at least in other ways, bitmap is quite a bit superior to the stupid allocator. So it'll just be nice to know what the trade-offs are.
Yep.
All right. All right, there's this avoid traversing all dir frags when trying to get right locks, I assume. I have no idea what that is. But yeah, it apparently emerged. um, let's see, what else do we have here? Oh, so there's an outstanding pull request from Doug to increase the default RGW thread pool size. And unfortunately, it doesn't look like Matt's here or Yehuda, but I suspect that would be good to do. Honestly, maybe even increase it larger, given kind of the way that RGW works currently. But yeah, that's probably makes a whole lot of sense to merge. Erwin has been doing a ton of work on optimizing make check performance and just kind of build performance in general over the last couple of weeks. And just in IRC this morning, he was talking a little bit about it. It looks good. With especially the work that he's been doing on caching recently, it looks like he can reduce a build from like 30 minutes down to like 7 minutes. So the gist of it is, well, these make check performance improvements are one part of it, but the one that I really remember recently was that we're really doing a horrible job of actually utilizing the cache in make in CMake, because we introduced like a lot of randomization, or at least some randomization, and so they can't really make effective use of it. But anyway, so he's looking at all of this, and my hope is that once he's done with this, our builds are going to be a lot faster, which at least for me would be a huge improvement because I'm rebuilding pretty constantly. So anyway, that's exciting. Let's see. Adam was working on aging tests for Bluestar allocators. I think that's just kind of tied in with all the other fragmentation work. There's a couple of other semi-recent pull requests here that haven't had a whole lot of movement. This shared persistent read-only RBD cache, that's been around for a while. I'm not sure what the current state of that is, but apparently it's continuing to get discussion and updates here. So There's this async recovery PR from Aaron85, and just from what I've heard from Sage on this, it sounds like this is something that Sam attempted something like this a while back and had no luck with it. I mean, you can see it in the PR there, but yeah, it sounds like this may not actually be worth attempting again. Redick has been doing a bunch of stuff on huge pages, looking at huge pages. Redick, is there any movement on that one?
Hello. Basically, it's the pull request is ready to go. It has some drawbacks related mostly to the involvement of administrator to configure the size of a huge page pool. However, this is I'm afraid we wouldn't be able to overcome that. It's just a system limitation. If somebody wants to use explicit huge pages, he needs to tell kernel about the pool, about the size, about the number of huge page he wants to have. So it can provide a nice boost at the cost of extra maintenance burden, I would say.
So in all of the stuff I've been working on recently, looking at memory allocators and madvise and other things, it looks like there are limitations once you start using huge pages. Have you seen that as well?
There are, of course. However, I am pretty sure they don't affect us, as we are not using huge pages with tcmalloc or jemalloc or any kind of system memory allocator. We are just have something very, very simple that goes directly to mmap and munmap. So we are
Okay.
eliminating those huge pages on our own.
Okay. Yeah, that's probably the way to do it. Okay, cool. That sounds good. All right. There's lots of other stuff here. I don't think Eric's around to talk about whatever's going on with the IO throttler. Redick, there was I said I like to say a lively discussion regarding the op tracker optimization that I think you and Peter were having a while back. Is that
Yep.
kind of just is that done?
I think so. Yesterday we had a good and long video call regarding the op tracker and testing environment. It turned out that Peter, that we had a huge difference here. I was using on Inserta. I'm using CBT, which by default disables Ceph. In a way, it's very, very similar to what Intel and Samsung are doing in their own tests of maximum IOPS scenario. Peter was testing with vstart deployed cluster with Ceph on board. So we think that Ceph be bottlenecking much earlier than the spin lock contention pop-ups. So the optimization around the spin lock we have in OpTracker, in OpHistory manager, could be visible mostly on very, very powerful devices, and all SSD configurations or something like that. On HDDs, it gives well, it's not visible. It's just not visible. So it's not. I would say that this optimization is not generic, but still worth adding as we are targeting those very fast devices. Also, we have a discussion about worthiness of optimizing divisions, and it turned out that, as usually, it depends. First of all, the custom of division operation on x86 is variable and can vary from just 9 cycles in the very optimistic scenario to up to 90 cycles. For instance, 90 cycles is about it's just the cost of L3 cache miss and need to go directly to system memory. So it's pretty worth. However, in the exact case of tracker divisions, I feel I get they are worth at least 30 or 40 cycles, which is comparable to cache to L2 cache miss covered by L3. But
Okay.
of course, the optimization it's not the most important part of the pull request. Definitely, what has been done in the continuation of this pull request is integrating our P2T wrapper for power of tools. It's a type for it's a language facility to convey the information that we are dealing with power of two using language systems type. The outcome is that we are integrating that the P2T has been integrated with config subsystem. This means that we have the validation made just once, just during parsing of our config. Then we can safely use those optimizations almost everywhere. So it looks bulky, I would say.
Are you going to keep that all in one PR or break those apart?
Well, I have one huge branch with all those things.
Okay.
Basically, everything that is in the old OptTracker pull request, plus some optimizations related to create a request of OptTracker, plus some optimizations for IO throttler, making a bond between shards of OptTracker with shards of our main work queue. Well, a lot of commits there. There is a branch.
It could be really good if we could just find, like, since that one was so contentious, if you and Peter are kind of in agreement on what's okay, if we could get something, with that one merged.
We agreed that this branch will be sent to review today or maybe tomorrow.
Okay.
I have it on my GitHub. Let me provide you with a link. Here it is. It turned getting back for a second to the differences between environments. We also spotted that there is difference in the throughput our machines are providing. Insert those the values related to performance comparison in the pull request are in kilobytes per second. This means that the single insert node delivered 3 and or over 3 gigabytes per second, while the vstart deployed cluster was able to deliver not more than around 1 gigabyte per second.
Sure.
So I guess that's the reason why the contention on spin lock wasn't noticeable in the V-Star testing.
Sure.
Ceph X and one socket configuration instead of two socket configuration we have on Incerta.
All right. Here, let me get back to my page here. All right. There's not a whole. I mean, there's a bunch of random old stuff here, but I don't think any of it's worth talking about probably, since none of it has been updated in a while. Let's see. The only other thing I was going to mention is that there has been some discussion recently about memory allocators again, and whether or not it would be worthwhile to reconsider the libc memory allocator. And so over the past week, we ran some tests taking a look at that again. Here, I'll share my screen. Can folks see this?
Is it possible to zoom a bit?
Is that better?
Nice is good. Now is good.
Good. Okay. So this isn't that interesting, to be honest. I mean, it's kind of what we've already known, but it's good because it's recent. This is on an Ubuntu 1804 system using the most recent libcmalloc that includes the Tcache optimizations. So the gist of it is that we're still libcmalloc is still really bad at using lots of RSS memory, presumably due to fragmentation. We don't have direct evidence of fragmentation, but this is probably indicating that there is some. tcmalloc really, I think, probably continues to have kind of the best behavior here. You could make an argument that jmalloc is probably pretty close. The vert size is higher, but the actual RSS memory usage is maybe a little bit lower than tcmalloc is. And this is kind of an old version of jmalloc, so the newer version might be better. I don't know. But both are using significantly less memory, both vert and RSS, than libcmalloc. And there's no real performance advantage to libcmalloc either in this case. So these were RBD results, 4K random writes using an NVMe device with 3 GB BlueStore cache, 1 OSD. And then also we looked at RGW small object creation. And the story is maybe actually a little bit better for libcmalloc, but it's still not great. It's still using not quite double the memory of the other two, but still really high. So yeah, I mean the gist of it is that I don't think there's a real compelling technical case right now for using libcmalloc. The only real advantage is that it's the default, pretty much available on any Linux distribution. No extra setup is necessary for it. But I think given these results, we'd need the libc folks to figure out ways to help us reduce this. One thing that they recommended was disabling fast bins via LD preloading shared object, because that's the only way you can disable fast bins right now. So we did that, and then also increasing the Tcache count, and that actually increased memory usage a little bit. I think basically what happened is the performance went down a little bit because we didn't have fast bins anymore, and the memory usage went up because we were now using higher than default Tcache count. But yeah, it didn't really help. So I also tried reducing the number of arenas. Kind of the community wisdom out there is that by using only 2 or even 1 arena, you might see increased threat lock contention, but potentially lower fragmentation. And that really did not work. I didn't even get to the random write case before the node had run out of memory. For whatever reason, decreasing the arena count made the memory usage spike very, very quickly, just pre-filling an RBD volume. It was up to like 11 or 12 megs of RSS before we even got to this test. So in any event, I guess the answer here is that if you want to try using libcmalloc, you should expect a very, very high memory usage, at least in current versions and current versions of Ceph. Any questions on any of this? All right, I'm gonna close it up here then. All right, so that's all I've got this week. Is there anything anyone would like to talk about? All right, well, have a great week, everyone. We will meet again next week.
Thank you.
See you later.
See you later. Bye.
Yep. Bye.